All right, here we go. So we talked about this one yesterday, or on Monday or Friday. Okay, here we go. Give that one a shot. Have a conversation. Okay. Correct answer is all right. So average velocity is displacement over time. Okay. I could expand that by that. Final position minus initial position over final clock reading minus initial clock reading. So my final position was 10 yards. My initial was 40. My final clock reading was 5 seconds. My initial clock reading, they don't specify this, but you can assume it's 0. So the correct answer is B. Beautiful butterflies. Okay, good at that. Now, often I'll write it out like this. I'll say average velocity is final position minus initial position over the time interval, just because usually your initial time is 0. So I just kind of write it like that. And write this as 5 seconds. Good with that? Okay. Now, how does the sign or the direction of velocity compare to displacement? What would it have to be true for delta t to be negative? What would have to be true for delta t to be negative? You would have to go back in time. Guess what's not going to happen in this class? We are not be time traveling. Okay, so delta t will always be positive. Therefore, whatever the sign of displacement is, that's always going to be the same sign as velocity. Does that make sense mathematically? Okay. So what does that communicate? Which way you're going. Okay, so velocity and displacement will always have the same sign. So I'm going this way, I have a positive displacement, I have a positive sign. I'm going this way, I have a positive displacement, a positive velocity. If I'm going this way, I have a negative displacement, I have a negative velocity. Okay. If I'm going this way, I have a positive displacement, positive velocity. If I'm going this way, I have a negative displacement, negative velocity. Good with that? Displacement and velocity will always have the same sign. Okay. Tell your neighbor. Okay, correct answer is B. Beautiful butterflies. Okay. What's another name for the magnitude of velocity? The speed. Good with that? Tell your neighbor. Correct answer is D. Dangerous dinosaurs. Good with that? It's going faster, has a greater magnitude, absolute value. They're going in opposite directions because of the signs. Good? Okay. All right. Example problem. A tourist is fishing and looks up, sees a bear 26 meters away. Looking at him, deciding to make a break for it, he bolts towards the car, going 4 meters a second, while at the exact same time the bear takes off, going 6 meters a second in the same direction, trying to catch the tourist. What is the furthest position that the tourist can be away from his car so that he reaches the car just as the bear reaches him? Okay. Step one is to draw a picture. Okay. Your pictures do not need to be elaborate. I kind of have fun with them, but you can just draw boxes. So there's your dude. There's the car, and the bear's coming. Well, that's a big bear. Okay. So we've got 6 meters per second. We got 4 meters per second. This distance we don't know, but we do know if there's 26 meters, initially between the bear and the tourist. Good with that? Okay. Now, here's another thing. If I don't specify which way is the positive direction, make the way they're moving the positive direction. That way, distance and so long as you don't turn around, distance and displacement, it's kind of the same thing, and velocity and speed, the same thing. So I'm going to make to the right positive and to the left negative. Okay. To solve this problem, there are two different ways to do it. There's the tried and true way to do it, the longer way, and then there's the intuitive way. Early on, many of you will be able to figure out the intuitive way. That's fine, but that as we move through the year, the ability to come up with an intuitive solution becomes harder and harder. So just embrace the tried and true. Like it's all right. So big picture, here's what we're going for, the tried and true. If you have multiple objects, you need a set of variables and an equation for each object. Okay. So we're gonna have the bear, and we're gonna have the tourist. Okay. The bear has a velocity of 6 meters per second. Is everybody okay with the little subscript for B for bear? Velocity sub B for bear. Okay. And the velocity of the tourist is 4 meters per second. I am looking for how far the tourist can be away from the car. That's what I'm looking for. Now, I've been given another number. It'd be really nice if I could like fit that in there somewhere. 26 meters. Is that how far the bear ran? Is that how far the tourist ran? Like, how do I use 26 meters in this? So the displacement of the bear is equal to 26 meters plus the displacement of the tourist. How are we doing with that? Velocity of the bear plus the tourist. Sorry, the displacement of the tourist plus 26. Okay. Now, the only equation that I have in my toolbox at this point is that. Okay. So I'm probably going to need something with time. Got velocity, got displacement. Which object is running for a greater amount of time, greater length of time, the bear or the tourist? Okay, for this, usually I let you have a conversation, but activity period is preventing us. So, on your marks, get set, go. Stop. Okay, ready, set, go, stop. Which one ran for a greater period of time? That bear ran for a greater distance, but they both ran for the same amount of time. Ready, go, stop. Does that make sense? Okay. So I'm like, all right, I don't know what that is, but I do know algebra, so I'm okay with just writing that as a variable. And I know that that is the same as the time for the tourist. Okay, time of the bear is the same as the time of the tourist. Now, that's my set of variables for each. And now I need an equation for both of them. Well, I only have one equation at the moment that I have to work with, and that's this one. So I've got the velocity of the bear is equal to the displacement of the bear over the time of the bear. And the velocity of the tourist is equal to the displacement of the tourist over the time of the tourist. So I have the variables and an equation for each object. Okay, and that's going to be, so anytime you've got independent motion, so two objects moving independently of each other, or you've got one object traveling certain motion in one half and then another motion in the other half, there needs to be variables and an equation for each state of motion. Big picture. Okay, so this is what I would consider the physics aspect. Setting it up, the rest is just going to be math. Okay, so what I've got is 6 meters per second is equal to 26 meters plus the displacement of the tourist. Over the time. I'm not going to make a distinction between the time of tourist and time of bear because they're the same. And I've got 4 meters per second is equal to displacement of the tourist over the time. Good with that? Okay. Now, how many unknowns do I have? 2. How many equations do I need to have in order to solve for 2 unknowns? 2. You need a system of equations of 2 equations for 2 unknowns. However many unknowns, you need that many equations. Okay, so here we are. We got 2 unknowns, but I've got 2 equations. So to solve for this, I can do a ton of different ways. Substitution, elimination, there's whatever meets your fancy. Okay. Here's what I picked at the beginning of the day. I'm just going to run with it. Like, okay, I know that time is equal. So if I set both of them equal to time, then I can set those equations equal to each other. It's one way you can do it. It's not the only way. Okay. So I'm going to bring time over. So I'm going to multiply delta t on both sides. And I'm going to get time by itself. So I'm going to divide by 6. Okay. So I end up with delta t is equal to 26 plus delta T, or sorry, delta displacement of tourists over 6. And here, I'm going to do the same thing. I'm going to do times delta T on both sides. And I want to get 4 over on the other side, so I'm dividing by 4. So I get delta T is equal to delta X over 4. Good with that? Okay. From here on out, I'm not going to change colors. I'm just going to roll with it. Okay. So I know that the time are the same, so that this quantity and this quantity are equal. Good with that? So I'm going to set them up equal to each other. I'm going to bring that over here so we have a little more board space and everybody can see. So I'm going to say 26 plus delta X over 6 is equal to delta X over 4. I'm going to cross multiply. So we got 4 times 26 plus delta X is equal to 6 times delta X. I'm going to distribute to get 104 plus 4 delta X is equal to 6 delta X. Subtract 4 delta X on both sides. End up with 2 delta X is equal to 104. And delta X is equal to 52 meters. Okay. So that is the tried and true way to do it. Okay. List of variables and equations for every part that has an independent part of motion or independent motion. Okay. The intuitive way to do it is to say, hey, check it out. The bear is running 2 meters a second faster than the guy is. Okay, so you can pretend like the guy is at rest and the bear is going 2 meters a second. How much time would it take to go 26 meters if the bear is running 2 meters a second faster than the guy? Take 13 seconds. And then 13 seconds, how far can the guy run in 13 seconds? 52 meters. And so that's the intuitive approach. I'm fine with you doing that. Just make sure you communicate with me how you did that, so you just don't see a number and like, oh, that's nice. You just copied that off of somebody. Okay. So that's the problem. What? Yeah, totally. Good? Okay. All right. So we've got you're jogging 4 meters a second for 20 minutes, and then you walk for 2 meters a second also for 20 minutes. What is your average velocity for your entire workout? Okay, to figure this out, we've got two sets of independent motion. You got the jogging phase and you got the walking phase. So you need a variables and equation for both. So you've got your velocity of your jogging is equal to your displacement of your jogging over the time of your jogging. The second phase is walking. So you have your velocity for walking is equal to your displacement for walking over your time for walking. Okay. Your average velocity is equal to your total displacement over your total time. And that can be found by this. Your displacement of your jogging plus your displacement of your walking over the time of your jogging plus the time of your walking. You okay with that? All right, so I'm going to truncate this time. So the answer to this one is 3 meters a second. And you're like, Mr. Smiley, that was stupid. Like, why would you go through all of that? Just like, hey, the average of 2 and 4, that's 3. Okay, well, that's great because we're going for equal amounts of time. But let's say we change the situation and we go 100 miles. For the first 50 miles, we're going 80 miles an hour. And then the second half of the trip, last 50 miles, I'm going 60 miles an hour. What's the average velocity? It's not 70. Okay? Which were you going for a longer period of time? The 60, going 60 miles an hour or 80 miles an hour? Took you longer to go the last half because you're going slower. So you're traveling 60 miles an hour for more time than you're going 80. Therefore, it's going to be less than 70. To figure out the actual amount, you have to go through this math here. Okay? So your activity period. You got a worksheet due tomorrow. No. It's on campus. On campus. Woo!